So as we see the equation x squared equal to 5, we clearly understand that x and y are swapped. So in place of x, I have y, and in place of y, I have x. That means the x and y coordinates are interchanged. So in this case of the parabola shifts to y-axis. Say for example, I have the x-axis and the y-axis. The parabola is in this form. So this is how we get the parabola, where the vertex is 0, 0, and my focus would be 0a. So a0 shifts to 0a because x and y are swapped. X and y get interchanged, and hence each of its coordinates get interchanged, where a0 of the original focus gets shifted to 0a, where this is shifted here and this is shifted here in this form. So I get the focus to be 0a, and then with the point P, with the locus x, y, I get the directrix with this perpendicular to this. So the axis out here is this, given by the equation x equal to 0, and the directrix is here, given by the equation y plus a equals 0, is what we get. So each of the focus, the vertex, the directrix, and the axis are given with their respective equations out here. Y plus a equal to 0 is the directrix. For the parabola, x squared equal to 4ay. Now lastly, we have the type of the parabola in the form x squared equal to minus 4ay. So in this case, I clearly see that my y is replaced with minus y. That is, all the y coordinates are replaced with negative of, which makes me understand that if I have x-axis and y-axis, all my y's are replaced down. Therefore, the parabola would be downwards in this form. So if I take the axis out here, I get a parabola in this form with the vertex v equals 0, 0. And I have the focus S, which is given by 0 minus a, because all the coordinates get replaced with minus 5, so a gets replaced down here. Now in this case, I have a point P, which is xy, from where I take the directrix line and drop So this is how I get this, where my vertex is this, my focus is this, and my axis is x equal to 0, and my directrix equation is given by x y minus a equals 0. This is how I get each of the properties in for the parabola, which is in the form x squared minus equals minus 4ay with a greater than 0. Now let's take the equation of the parabola in standard form as y squared equal to 4ax, which is called the standard form of representing the parabola. Now with this, I clearly see that when I have this parabola in the form of x and y, I clearly see each of the x values are positive and are not negative, because y square equal to 4ax is defined only for x greater than or equal to 0. If I take a negative value, this reduces to the root of a negative number, which is complex or imaginary. Therefore, this being y square equal to 4ax is defined only for x greater than or equal to 0. Therefore, the first property which I identify in case of parabola is that y square equal to 4ax is always on the right hand side of y-axis, or in the positive direction of x-axis, or in positive direction of x-axis. It cannot cross the negative direction of x-axis, as you can clearly see out here. So let's see the next property which is identified for the parabola y square equal to 4ax. So examining the second property, I clearly want to investigate on what happens if I extend the parabola. What happens in the endpoints of parabola as I go on and on till the infinite distance. So in case of this, I clearly identify that as I proceed towards the right, the parabola starts opening up and the points move farther away from x-axis. This is because if I take, say, x tends to infinity, implies y square equal to 4ax, that implies y square tends to 4a times of x, which is infinity. Therefore, this on simplification gives y square tends to 4a times of infinity, which is infinity. That implies y tends to root of infinity, because when y square tends to infinity, y tends to square root of infinity. That implies y tends to infinity. Therefore, x tends to infinity implies y tends to infinity. And this makes us understand that when this x-axis goes till infinite distance, the points move infinite distance from x-axis towards y-axis on either side. So therefore, this opens up at infinite distance on the right, and therefore it is not closed. The parabola on the right is always an open curve. Therefore, the parabola opens up in the positive direction of x-axis. That is, y square equal to 4ax is an open curve. Just like a circle which is a closed curve, parabola is not a closed curve, as supported by this mathematical property. A parabola is an open curve and a circle is a closed curve. Translation or shifting of the parabola. So let's see what happens if I shift the parabola from origin to any other place in all the four quadrants of the xy coordinate system. So translation or shifting of the parabola. Say for example, I have x-axis and y-axis. Say my original parabola y square equal to 4ax is shifted with vertex v00 to some v dash hk. That is, the vertex which is origin is shifted to v dash as some hk. So this being shifted here gives me the new vertex which is hk. So using this, the parabola equally shifts out here, which is obtained like this. Now this has the axis and it has the directrix and it has the focus, which we're going to define through the original axis. So this parabola, which is translated here, is referred with y square equal to 4ax, which is translated along the point hk, gives us the new parabola, which is y minus k whole square equals 4a times of x minus h. Is the parabola out here, and the focus s, which s dash, which is ak for the original, a0 for the original, gives us a plus h comma k for the new parabola. And next, the axis of this parabola is given by the original axis for this being y equal to 0, gives us y equal to k. So the equation of axis is y equals k if the vertex is hk. Next is equation of directrix. Which in the previous case was x plus a equal to 0. So here my x coordinate being a plus h gives me equal to 0, or this can be x equals h minus a. This is how we get the directrix. So usually we assume this point to be x minus h and y minus k, which is generally the coordinates of x and y, through which we get each of focus, axis, directrix, etc. So equation of directrix is this, focus, axis is this, focus is this, vertex is this. Is how we get each of the properties which we define out here. So translation of a parabola from the vertex from origin to hk gives me the focus, the directrix, the axis given by these formulae. So now that we have discussed about a parabola and its properties, the next is about chord. As we have the chord for the circle, which is through the secant, similarly the line joining 2 points of a parabola is called the chord of the parabola. So if I take a parabola say y square equal to 4ax, then in this case the chord of the parabola is nothing but I take the 2 points P and Q and I just join the 2 points. So these 2 points form the chord. So here PQ is the chord, is referred as the chord of the parabola. So chord is the line which joins 2 points of the parabola, any 2 points of the parabola. The next is the focal chord. So what do you mean by focal chord? So a chord which passes through focus is called the focal chord. So now that we have discussed about the focus, let's see how a focal chord is obtained. Y square equals 4x. Now we know that a focus is the distance from vertex to to S. So the chords which pass through the focus, say for example, I take a chord which is passing through the focus, then this chord is called the focal chord because this exclusively passes through focus. So here PQ is called the focal chord because this passes through S. Now any line which passes through the focus is called the focal chord. Now as we can see here, there are infinitely many chords which pass through the focus. So the property here is that there exist infinitely many focal chords for the parabola, simply because there are infinitely many chords which can pass through the focus, and hence the focal chords are infinitely many in number. Now next is the double ordinate of the point. So what is double ordinate? So now that we have discussed about the chord and the focal chord, a double ordinate is referred of the point P. The locus is referred to the point P. Therefore, if I take a parabola with axis, x-axis and y-axis, then if I take the locus pxy, then the double ordinate of the point P is a chord which is perpendicular to the axis of the parabola. So a chord which is perpendicular to the axis of the parabola is called the double ordinate. So here we need to understand that this is the axis and chord PQ is perpendicular to axis of the parabola, that is y equal to 0. So any line passing through P and which is a chord and which is perpendicular to the axis of the parabola is called the double ordinate. Is how we understand the double ordinate. The reason for double ordinate is if I take this as y and this distance will also be y, and therefore when you add I get 2y. Therefore the length of PQ is y plus y, and that is 2y, and this is double ordinate y, that is 2 times of y. Is how we understand the double ordinate connected with the chord of the parabola. Lattice rectum. So let's understand what exactly is a lattice rectum for the parabola. Suppose I take a parabola with x-axis and y-axis in the form y square equal to 4ax. I have the vertex here and my focus is out here. So lattice rectum is defined as the double ordinate which passes through focus. A very simple definition where a double ordinate, lattice rectum is a double ordinate passing through focus S. Now as I see here, interestingly, there is only one line which is passing through focus and perpendicular to the axis, which is called the lattice rectum. So here L dash is referred as the lattice rectum, and it is very important to note that there exists only one lattice rectum for the parabola, because there's only one line which passes through the focus and which is perpendicular to the axis of the parabola. There exists one and only one lattice rectum for the parabola. Is how I understand the geometrical property of a lattice rectum. Chord, there are infinitely many chords for the parabola, and focal chords, there are infinitely many focal chords. Double ordinates, there's one double ordinate for that one particular point P, and lattice rectum, there's only one and only one lattice rectum for the parabola. Is how we understand the chords connected with the parabola. The four types being chord, focal chord, double ordinate, and the lattice rectum.